Section 6.4, Properties of Rhombuses, Rectangles, and Squares. A rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And a square is a parallelogram with 4 congruent sides and 4 right angles. Something to keep in mind down here is that squares can be considered both rhombuses and rectangles, but rectangles cannot be considered squares, and rhombuses themselves cannot be considered squares. Decide whether the parallelogram is a rhombus, rectangle, or square. Explain. And we want to use the most inclusive title for each. So in this case, we have 4 congruent sides. We don't know any of the angles, so the best we can do here is a rhombus. Here we have 4 right angles. Not all the sides are equal, so we're going to say this is a rectangle. Here we have 4 right angles and 4 congruent sides, so this is a square. And here we've got congruent sides. We've got a right angle here. Well, because of the parallel markings here, however, if this is 90, we know it's supplementary to this angle, which means this is also a right angle. Which then we can then recognize, all right, we've got a parallelogram, so we also know that consecutive angles are supplementary, so this is a right angle, as is this one. So we've got 4 right angles, so this is a rectangle. The properties of a rhombus. So if a parallelogram is a rhombus, then its diagonals are perpendicular. So if it's a rhombus, then the diagonals are going to form a right angle, or right angles in the middle where they meet. If a parallelogram is a rhombus, then the diagonals are going to bisect pairs of opposite angles. So this diagonal creates congruent angles here and here, as well as these angles here, where the other diagonal does the same thing here, and here, and there, and there. Here we want to use this information to determine the measure of the numbered angles in the rhombus ABCD. So we know that this is a rhombus. So that means that we can pretty much figure out angle 1 really quickly because we know rhombus's diagonals are perpendicular. So the measure of angle 1 is just 90. We also know that these angles here created by this diagonal are congruent since it's bisecting the opposite angles. So that means the measure of angle 2 is 58 and the measure of angle 3 is also 58. We could have also gotten this information from the idea that this is parallel to this. So 2 and the angle that are 58 are alternate interior angles. So we could have used that as well. So we could say AIA here if we wanted to as well. And then we know, we'll say diagonals bisect. All right, and then the last one we have to find is angle 4. Well, this is pretty straightforward. We already know the angle measures in this particular shape. We've got 58 here, we've got 90 here. And so the question is, what is 180 minus 58 minus 90? Well, that's just going to be 32. So that means the measure of angle 4 is just 32 degrees. So these are our answers. We want to do the same thing here. We have a rhombus and we got to find our angle measures. We know that this is a rhombus, so we know that this side is congruent to this side, and this side and this side. But essentially, this triangle is a isosceles triangle. So these two angles of 1 and 3 should be the same. So to find it, we're going to take 180 minus 104, which gives us 76, which is the sum of the two angles 1 and 3. Then we just need to divide that by 2, and we get that the measure of angle 1 is 38, which is the same as the measure of angle 3. But because we know diagonals bisect angles, we know 4 and 2 and 1 and 3 are all the same. So angle 2 is also 38. And we also know that angle 4 is also 38 degrees. So a property of a rectangle. If a parallelogram is a rectangle, then its diagonals are congruent. So the diagonals should be the same length. In rectangle RSBF, SF is 2x plus 15, and RB is 5x minus 12. What are the measures of the diagonals? Well, SF is one diagonal, RB is the other. So if we know their measurements, and we also know this is a rectangle, the diagonals are congruent, so we're going to set them equal to each other. We'll subtract the 2x over, we get 3x minus 12 equals 15. Add the 12 over, we get 27 equals 3x. Therefore, x has to equal 9. Once we know what x equals, we'll just plug it back into each of the measurements. So SF is going to be 2 times 9 plus 15. Which gives us 33. We also know that RB is going to be 5 times 9 minus 12, which is 45 minus 12, which is 33. So both of the diagonals are 33. In rectangle LMNO, LN is 4x minus 7, and MO is 2x plus 13. So these are our two diagonals, and we're dealing with a rectangle, so we're going to set them equal to solve. So we'll minus 2x, so we've got 2x minus 17 equals 13. Add the 17, 2x equals 30. Divide by 2, x equals 15. Now that we know what x equals, we're just going to plug it back in. So in this case, ln equals 4 times 15 minus 17, which would be 43. MO is 2 times 15 plus 13, which is also 43. Here they want us to determine the most precise name for each quadrilateral. So in this case, we've got parallel opposite sides. We've also got 4 congruent sides, so the best we can do here is a rhombus. Here we've got opposite parallel sides, so that means we've got a parallelogram. We've got all the sides are congruent, which would make it a rhombus, but then we have the presence of this right angle, which we can, from a parallelogram, we can put everywhere else because of consecutive angles being supplementary. So this is going to be a square. And then here we've got properties of a parallelogram. We don't have all 4 sides congruent, we just have opposite sides congruent, but we do have the presence of the right angles. So the best we're going to do here is a rectangle. Here we want to find the value of the variables, then find the side lengths. So for the rhombus, all of the sides are the same, so I would match up like variables. So x plus 14 equals 5x minus 2. And then we've got 3y minus 3 equals 2y plus 4. Now we're just going to solve for each variable. So for x, we'd subtract the x over, we'd add the 2, then we divide by 4, so x in this case equals 4. For y, we're going to subtract 2y over, add the 3, so y equals 7. With that, we can now figure out the side lengths of our rhombus. And we should get that every side has a length of 18. For the other problem, we've got a square, so we can do the same thing, match up the appropriate variables. So 5y minus 15 equals 3y plus 3. I'll subtract 3y, so I've got 2y. And I'll add the 15, so that's 18, so y is 9. Then I'll match up the x's, so I've got 4x minus 22 equals 2x plus 4. I'll subtract the 2x, so I've got 2x, add the 22, that's 26, divide by 2. Or divide by 2, so you get x equals 13. So now that I have those, I just plug them back in to get my side lengths, and remember it's a square, so all the sides should be the same. In this case, every side should be 30. Here's the wrap-up. Go ahead and answer both of the wrap-up questions on your own, or before you do that, pause the video, and then when you're ready to check your answers, unpause the video.